The video tutorial for Year 11 Chemistry Calculations, and in this tutorial we will go over essentially an extended response, and through answering the calculations in this question you will cover calculating moles using N equals M over M, calculating moles using the concentration formula, identifying limiting reagents in a reaction, inferring the moles of products produced using the reaction equation coefficients. Then you're going to use Avogadro's hypothesis to determine the volume of a gas produced. You're going to use PV equals nRT to determine the volume of gases produced in reactions, and also excess reagent calculations, so looking at the amount of reactant which is present after a reaction has completed. So you should be able to get this sheet from my class, and you can work on your questions as I go through the solutions on the screen. So what I would advise is for you to try a problem first. If you don't know how to do it, watch through the video, pause at appropriate times and copy down the solutions so that you're also working as you're watching. So we're going to go through the answers to the first question, question A, and we need to read the question first. So this question says 300 mils of a 0.4 molar, so that's moles per litre, phosphoric acid solution was poured into a container which was filled with 32 grams of solid calcium carbonate. A reaction was produced which involved vigorous bubbling, and the reaction equation is shown below. So in this question they've given you the reaction equation. This sometimes occurs and sometimes you will have to write the reaction equation yourself. This is an acid reacting with a weak base. So the products are carbon dioxide, water, and a metal salt. And the metal salt, its identity can be inferred from the type of acid, which gives the negative ion, and the type of base, and that gives the positive ion, so calcium phosphate here. Notice that the ionic formula for this is correct, and you need to be able to write your ionic formulas correctly in order to balance the equation correctly. So the equation is balanced here. They've given you the coefficients, and these will help you to answer the questions. So the first question says calculate the moles of the phosphoric acid and the calcium carbonate, and the first thing I'm going to do is calculate my moles of phosphoric acid. So I'm going to use the formula N equals CV to do that. That is just here, and I've put the data in. So we've got this information from the question. It says a 0.4 molar solution, that's the concentration, times by the volume of 300 ml, which you need to convert into litres in order for the calculation to work. So 300 millilitres is 0.3 litres. Times those together to get 0.120 moles. Notice I've put this in three significant figures. Throughout some of the questions I've forgotten to do three significant figures, so forgive me. Now I'm going to calculate my moles of calcium carbonate. In order to do this, I'm going to use the moles equals the mass over the molar mass formula, and I also need the molar mass for calcium carbonate. I've calculated that as 100.09 grams per mole. I've forgotten the units here. And then I'm going to divide my mass, which is given in my question, 32 grams, by the molar mass. I do that and I obtain the value of 0.319 moles. The next question, question B, says to identify the limiting reagent. So in order to do this, you need to look at the reaction coefficients, and you need to look at the moles which you've previously calculated for these two substances. So these are our two reactants, and we want to identify which one of these is going to limit the reaction because it has less moles than the reaction coefficients require. So if we look at our reaction equation, it says we need 2 moles of phosphoric acid to 3 moles of calcium carbonate. So I've written this as the mole ratio is 2 to 3. And if I put my values in for the moles that I do have, 0.120 moles of phosphoric acid and 0.319 moles of calcium carbonate, I can see that this does not reflect the ratio, and in actual fact, there is much less of the phosphoric acid than there is required to be, and therefore phosphoric acid is the limiting reagent in this calculation. The way to confirm that, the easiest way I know of, is to just take your lowest number and divide it by your highest number in your ratio to get the expected percentage of your lowest substance compared to your highest substance. So that's 0.67, or there should be 67% the amount of phosphoric acid to calcium carbonate. Then you do the same thing for this. So you'll do 0.12 divided by 0.319, and this is saying that 0.376, there's only around 38% of this compared to this, and therefore there's less of this than required, so it is the limiting reagent. The important thing about limiting reagents is that you would use this mole value for subsequent calculations of the moles, masses, and volumes of products. So now that we've identified our limiting reagent, we can start calculating the moles, or the amount of products produced. And the first question says calculate the moles of water. Now this is very easy because all you need to do is use the moles of your limiting reagent and the coefficients in the equation. So I know that the amount of water required will be 3/2 the amount of phosphoric acid. So what I would do is I would go 3, the substance I'm interested in, divided by the substance that I know, the coefficient there, 2, times by the moles of the limiting reagent, phosphoric acid. So the moles of water will equal 3/2 times by the moles of phosphoric acid, which equals 0.18 moles. Question D leads on from there, and it says to calculate the mass of the water produced. And that's very easy because you are already familiar with the formula of N equals M over M, and I just rearranged this to find mass instead. So I put in my value of moles, which I've just obtained, 0.18, multiplying it by the molar mass of water, 18.016, to obtain the mass of water produced, 3.24 grams of water. This next question is very similar, saying to calculate the moles of carbon dioxide, so you can follow the same process as was done in question C here. So you're going to use the moles of the limiting reagent and the coefficients in the equation to make sure that the amount of carbon dioxide you're obtaining is correct. So the relationship is 3 carbon dioxides to every 2 phosphoric acid, and we can express that as 3/2 multiplied by the moles of phosphoric acid. 3/2 times the moles of phosphoric acid, 3/2 times 0.12 equals 0.18 moles again. It's the exact same calculation as this. The reason it's the same calculation is because these have the same reaction coefficients, and we're comparing it to the same substance, which has obviously the same reaction coefficient. Now we get to some of the gas questions, which, though we've covered quite a lot, you're probably less familiar with because you've had less time with them. But two things that are often asked are to calculate volumes at standard temperature and pressure and standard laboratory conditions. So the first thing we're going to do is calculate the volume of this gas, the carbon dioxide produced, at standard temperature and pressure. So it's very easy because we can use Avogadro's hypothesis for this. Avogadro's hypothesis is found on your data sheets, and this simply says that the moles will equal the volume divided by a constant, which is 22.71, when you're using pressure in kilopascals. So you're nearly always using pressure in kilopascals. So you just go 0.18 moles. That's what I calculated in the previous question as the moles of carbon dioxide. And then solving for volume to make 4.09 litres of carbon dioxide gas produced. If I would look at standard laboratory conditions, the actual conditions are different to standard temperature and pressure. In standard laboratory conditions, we have a temperature of 25 degrees Celsius, not 0 degrees Celsius, and a pressure of 101.3 kilopascals rather than 100 kilopascals. So both these values, 298 degrees Kelvin and 101.3 kilopascals, are larger than the values for standard temperature and pressure. So as we increase the pressure and we increase the temperature, we would expect the gas to become larger. So we'd expect the volume to increase. So I'm going to use PV equals nRT to solve this question. P is my pressure, I'll place that in. V is my volume, that's what I want to find out. N is my moles, 0.18 moles. R is the gas constant, and this is 8.315 when using kilopascals. And my temperature is 298 degrees Kelvin. So I put all these factors in and I solve for volume. I get 4.40 litres, which is slightly larger than for standard temperature and pressure. As I said, this is what you would expect. So make sure that you do these calculations and you're confident with using both of these formulas.